Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 79, booking concert tickets in groups. Um, Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, maybe even in the discussion forum. I'll let you know what I think about this problem. The two things, well, one is I assume that you've already read it, so you know, uh, but one is that, spoiler alert, this requires some form of sig tree. Apparently, some other languages you can do some smart brute force, but nonetheless, um, for the most part, most reasonable solution is going to be using something called a segment tree, and yeah, and that is just silly in a number of ways. One is that I don't believe myself. I don't believe seg tree is should or segment tree should be on any interview, any reasonable interview. I've heard that. I've heard from time to time that certain problems require seg tree, but I feel like in general, at least if it's a reasonable interview, that it wouldn't require it. It's just that seg tree is one of the solutions because it is a very flexible data structure. It is one of the solutions, but it is not the solution. Um, that like there are other solutions, so it's not a seg tree problem per se, though you could solve it using seg tree. That's what I maintain. And two is that this is not an interesting problem because if you have the library, everything else is just very simple. And then the third thing, which I lied about the number, I guess, is that Leetcode is very bad with respect to Python. So yeah, I don't know if anyone got AC during the Python. If someone did, send me a link or the rank or whatever, so I can look it up. Maybe I have places to learn as well. But anyway, that said, yeah, I think Leetcode is just kind of messed this one up, both in context because, like I said, I don't know. Maybe if I'm missing a possible solution to this, let me know in the comments. But and it won't be that much longer of a rant. But yeah, I don't think this is within scopes of interviews. So and I put the money where my mouth is, to be honest, in the sense that if you watch the video of me solving this live, I actually spent a good amount of time trying to figure out a non-sig tree solution during the contest. I kind of gave up near maybe midway through and tried to do it, and then it time limit succeeded. Spoiler alert, but you could watch it if you like. I also kind of did it with binary index tree as much as I can, but didn't do it that way. Um, yeah. So those are the things, right? And then I would also say that if you do get a seg tree in an interview, let me know in my Discord probably. And also, they probably aren't hiring too much. Maybe it's the hiring freeze. Maybe your interviewer hates you because it's kind of tough to get it in within interview time, and also like in terms of all the typing. Like maybe if they let you use an abstraction, like maybe if even then I disagree, but maybe if they let you have an abstraction versus implementing it yourself, then maybe that's okay. But anyway, so how did I get it correct ultimately? Right, I did not solve it during the contest. I'm kind of salty about it, not gonna lie. I did it by writing the same exact code, but in C++. Maybe those of you who are, yeah, it is what it is, right? So if you're here for Python, it is a sad day. So I do have the C++ code, which is just, let me just show it real quick. This is so that you can pause it at home. Wow, it just keeps going, doesn't it? There's already a lot of code in general, 135 lines of code. I mean, maybe it could be tighter, but because I have a lot of spaces, and you know me, I love spaces. But we'll go with the Python code real quick instead, because it's the same exact code. This time limit succeeded, but like I said, C++ is the thing here, and maybe it's one of those days where I give up on Python for Q4 because I feel like at a certain point, clearly Leetcode is unwilling, and I don't know. I don't know why I'm, like if I have any doubt, use C++, right? I think Josh already does this, numbers already does this, and I've been kind of stubborn about it. But at a certain point, like fool me the first 10 times, shame on you. For me the next 20 times. Shame on me, right? Maybe this is a shame on me moment where, okay, I need to stop using Python for Q4. Let me know what you think. And if you think what I'm saying is silly, leave a comment on the Leetcode discussion forum saying that Larry mentioned this because, yeah. But okay, going back this problem, I am maybe one day I will do a segment tree video because it's something that I actually. So I know this is a long intro before you even got into the problem, but I would say that two things. One is that, like I said, I put money where my mouth is. I always try to not find the sig tree or like find an alternate solution that's not sig tree. So that said, I actually did not know sig tree before this problem, or rather, I know the ideas behind sig tree, but I've never implemented it. Maybe once, like by copy and pasting on a non-Leetcode contest, like I copy the library or something like that. But I've never implemented it. So this time I was like, okay, let me actually at least try to learn this. I don't know how you feel about that, but that said, do some Googling. I'm not gonna go over seg trees that much, just because it's gonna make this video is already long. It's gonna make this video very long. Leave a comment for support if you want that video. Maybe I'll do it at some point in the future. Okay. So what do you need to know about seg tree? I also missed about the problem, but that part is my fault. But yeah, what do you need to know about seg tree? Segment tree has basically two functions, right? One is update. So it updates, let's say, an index at X, right? And then another is get, I don't know, let's just say left, right? Something like this. It's not quite, yeah. So that's basically the idea. And there are a couple of ways you can implement the seg tree. You could have a sum version, a total version, a prefix sum version, or I guess not technically prefix sum, but just like a sum version, where basically what that means is that, let's just call it sum segment tree. Then now update still update, just updates the item on index to X, and then get left right, just return sum of all number of indexes left and right, left, right, inclusive, say, right? And then you can also have a max seg tree, which is the same idea. Update is still the same, and then get in that case would be return max of indexes left, right, inclusive. So let's say we're able to use this as an API. So that's what I'm gonna based on. Just because, like I said, I'm not gonna explain seg tree or like how it works, but this is basically the idea of it as a black box. And if let's say you're given this for free, we will now solve the rest of the problem. And also just to give complexity so that you know why we're using it, and it'll be more apparent later. This is all log n, and this is also log n, and n is not necessarily the number of items. N is you go to the number of max items, right? Or max number of items. Sorry, that's more clear. Meaning that in this case it would be n for number of rows. But this is the situation. Okay, I'll pause a second so that you understand. I'm not going over this. I have code for it, and I'll go through it very quickly, but not gonna. Let's just say you have these things, right? So I have max total. I have total. So I have max, and this is more like a sum total. The idea, the code is very similar. I just have a max segment tree and a total segment tree or sum segment tree, like we said. We built this from scratch, and then this is just the update function. Pretty standard stuff if you know if you know seg trees. Like I said, let me linger it a little bit so that you can kind of maybe play around with it. Like I said though, this code times out in Python, so maybe it's not that useful. And it is also a newbie code for me because I I don't yeah, it's not something that I've done. You know, this is my first time implementing it from scratch, so yeah. And this is the build. I call it max build because initially I had it. I had it. If you look at how I did it, I actually had a segment tree and a binary index tree. Also, I'm not going to go over that, but this is the solution I'm going over. And then this is just update as well. Yeah, and this is standard-ish stuff if you're familiar with the ideas. If you're not, you have to learn somewhere else. Sorry, friends. Okay, so we'll go over the gather step. Now, let's say we are giving those things. Oh, well, let me actually talk about the initialization first. Well, first, I actually have two more things. One is the first empty, which is that the first row that contains at least one empty seat. And this is built, basically, initialize every item to, yeah, to each row to m seats. That's basically what this is saying. Yeah, that's pretty much what I'm doing. And then now, given all these things together, the gather step is just, okay. So then now we can ask these questions in a more intuitive way. The code's a little bit yucky, but still, it's go, okay. Is there a row within the first max rows where there is at least k seats available, right? So basically, this is that's what I wanted to ask. And in code, what I'm actually asking is, what is the max of the first max available seats of the first max rows? And is it bigger than k, right? Because if the max available seats is greater than k, that means that we have enough. If not, then we just return this empty thing, because that means that in the first max row, we don't have enough seats for k people. And yeah, and how I did it is by using binary search. After that, it's basically going, okay, there exists a row which contains at least k seats. Let's find it, right? And how we find it is just by using binary search. It goes, and I'm not going to go over binary search that much in this video, because again, this is a really long video. But basically it's going, we try the middle, let's say, right? If the middle contains, if the first mid rows contains at least one row with k seats, maybe that's the way. Yeah, that maybe I'll add this here, right? Which is that yeah, okay, maybe I don't. If the first mid rows contains at least one row with k seats, then let's try. In this is this case, I suppose. Let's try something smaller. And this is, so we narrowed our search range to something smaller, inclusive, because, well, let's try something smaller so that we'll see if it still has enough row, right? Because we're trying to find the first row. Let's try to find the first row where this is true, right? And then if it does not, then we have to find something bigger. So then in a way, this is, in the beginning, we know that the answer is going to be in 0 max row, and then here it goes from left, the range goes from left right to left mid, right? Because now we know that the row that contains at least k seats is inside here, and here it goes from here to mid plus 1 right, because that means that none of the rows from 0 to left or 0 to mid, they cannot be the right answer. So that's basically the idea. And then after that, the gather is trivial in the sense that it's just keeping track. I actually put it in an array just to keep track, and I subtract k, and then I just update. This is called max update, but it actually is a regular update for both max and the total. And then I just do an update on this thing. Basically update row to this number of seats, and then I return the answer, which is the row, and then just the number of count. This is just mathy things. And then the scatter is, so this loop is going to be at worst case linear, but because I'm going to go over this loop in a second, but yeah, so basically, maybe I'll do it another way. But what I wanted to say here, I don't want to explain it too much yet. We'll explain it in a second. But this is expensive because this is at worst linear. So that's why we had to implement this data structure so that most of the time, so that we convert this from linear to amortized linear. And I'll go over why in a second. But that basically is why the statement of, okay, are there k seats in the first max rows combined, right? And this is of course where the sum comes into place, where if the total is greater than k, then then we go for it. Otherwise we return false, and this is pretty simple. I mean, you don't have enough seats in the first max rows, you don't use it. Otherwise we look at the first rows of empty seats, and keeping in mind that seats can only fill up, so this is okay, right? Basically we look at the first row, we keep on adding new seats, or we keep on using them one at a time. If the row is empty, we just increment and we go to the next row. Otherwise, we look at how many seats that we can take, and then we do an update, we subtract, and then we do an update, and then we need fewer seats, right? And also, if this is empty, we increment. I guess we technically don't even need this per se because they'll be used next anyway. But it doesn't really matter, right? Like we can remove this. Maybe, okay, let's just remove this then. So then the next time. And the idea is that once a row filled up, it cannot be used at all anyway, right? So because it cannot be used at all anyway, I guess maybe I could have optimized this by putting here, but I don't think that would have made that much of a difference. Maybe. Dun, dun, dun. But in any case, yeah, because this fills up anyway, yeah. Because now you're skipping the things that you've already processed. Instead of keep on going to max rows, it either uses the minimum row or it increments. And if it increments, then each row can only be filled up once. And so in that case, it is going to be worst case linear. And I say linear incorrectly maybe, but that this is linear number of loops is what I mean, because this actually takes more than linear time. But yeah, let's actually go over the complexity now, right? But because of this part can only because of this part we'll only do the number of rows. This is going to iterate at least or at most linear number of times. So yeah, and like I said, this is log n for the update, and this is so in total, of course, all the amortizations, this is going to be all of one amortized. Yeah, so yeah, all of one number of loops amortized. So O of log n total amortized, right? And for the gather, which we didn't do, this function is going to be O of log n, and this is also going to be, well, technically it's O of log max row, but that's going to be log n. So this is also O of log n, right? Well, there's going to be O of log n number of iterations to this, is what I wanted to say. but this function call takes all of log n time as well. No of log n loops and time. So in total, it's going to be of log n times log n time total, which is obviously, right? Which, it's fast enough conceptually, but apparently not really. And then at the very end, there's also a log n update here, but that's just a log n update. So, same thing here. So it doesn't change the complexity, which is this part. But yeah, that's all I have for this one, really. Like I said, let me know what you think. Let me know how you did. I did convert it to C++, and it did work at the, or at least it AC'd for me. So yeah, without any additional optimization other than changing the language. But yeah, let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later. And you can watch me solve it live during the contest next, including the time after the contest and a lot of frustration. But yeah, cool. All right, see ya. Okay. Maximum. Okay, so there are two things. You want to sit together, or they may not sit together. Okay, so this just kind of fills in that, except for the Maxwell part. Okay. Okay. So this always fills in. So it should be monotonically. No, that's not true. Okay. answer this pretty quickly. Which one is n in it? Okay, so the n rows. Okay, so times n, something like that. Let's see. Okay. No, obviously, for loops won't be fast enough. Oh, huh. So, oh, okay. Well, I thought that they would try to bait you into it, but yeah, if it's sent to the 9, they're clearly not really baiting you into it. But okay. So that is first one. The first one by C. C plus K. Okay, otherwise. By seats will be first entry. Yeah. Otherwise, this is good. I don't think this is actually needed, but what do I have to return? So and count is the thing. So m minus count. Oh, I have to put it back in. Let's see. Count minus. By what? It doesn't have to be sorted, right? No, I guess we should. You finished it, is it? We've already finished it. I think we're on the right track. Focus. Is this true? This part, actually, I didn't answer this really well. I thought I did, but maybe not. You have to get away quickly. The first. This should be a binary index tree, I think. See if this works for the other thing first. I guess so, but that's very basic. But I don't remember if that's true, but okay. Let's do that. And then yeah, okay, that seems good. just call it. Use consistent notation. Okay, I think this is right. I need this pre-written. We only need to do it once. Using inconsistent notations. That's not what I want to do. Okay. Okay, so that's the number of seats. Okay, so this isn't right, but okay, that's definitely not right. Because here we have to do something. don't know if this is right. I mean, looks okay, but way easy to have typos and stuff. So let's give it yellow. That was quick. It's not bad. It's just okay. Still a lot of time to do. Right, let's see. Which one is scatter? Scatter is the true false one. Well, false even though it's true. Why? Tell me why. Did do an off by one on the increase? Maybe I did. Okay, so that should be right. Okay, I always forget where I need to do this first index. But okay, so there's 5 rows of 9. So I put the right place. So 0, 2. Oh, well, 7 and 0, 2. And then 1, 0. For another 5, okay. 6, 2. So, I mean, max is 2 with 6, so this is 3 now. Not 2 in the first row. Why did I write false? Max could be 0, right? But huh. Subtract the wrong thing. What is going on here? Okay, fine. Okay. Oh, why is this 2? Did I messed up? Why does this go from 0 after using 2? I must have a typo somewhere. 0 delta, that's fine. So then why does it goes to 0, 0? Okay, so it goes to 7. Oh no, this is right. It tries to fit 7 people. Okay, that's good. I just misread it. And 4 is not right. I had 9 seats. I messed up some variables. Yeah, There's 9 seats. What happened? What happened? Oh, I am an idiot. Wow. This should be minus K. Oh, wow. Okay, well, that is silly. So many way. Oh, man. Okay, I mean, that was a silly mistake though, clearly. I should have double checked it actually. Double check what we want to do. Yeah, this is right though. Oh man, this is wrong again. There's so many typos. Is that now right? Let's see. This should be delta. Yeah, okay. Well, this should be. Okay, this is silly, Larry. Is this now right? No, still wrong. Still a lot of easy typos though, that's not great. People are getting it now, right? Yeah. Should have gotten it. Oh, gave away some minutes. This one I'm not so sure about though. I need also just auditing my code because I am being really bad about it. But okay, let's kind of work it out. 25 was a 941. 34. 34. Gather is the one where we care about it. So I'm just calculating. 34 plus 296 plus 34 plus 296 is 330. Used and then 927 is the first one. 695 is B, yeah. 5830 and 638 is the. Did I have it off by 1? Is that why? Let's see. I think that it could be in the second row, but it could be in the first row. Okay, I think this is wrong. This is me saying the first row that has enough seats, but this is sorted by. Okay, this is just the wrong logic. Okay, how do we do it then? This is a legit wrong answer. We want the first row that is enough, not the biggest row. Because by seats is now sorted by the seat count. And I assume that though I don't know. Oh no, 60. This one's on 638 is the one, right? No, 638 is the bad one. 169 is the good one. That definitely is fit in the same in the first. And then it just gets to the price of the smallest one, which is 269. Okay, I see why it's doing that, but okay. So now how do we do the first row that is available? We can do a can we do a for loop here, right? Wow, people are very fast. The first place which is smaller than I've misunderstood this part of the problem, so I'm thinking about it from scratch. This thing. How do you go through get the first number? Well, this is it. This allows me to know if it's possible. I'll use another binary index tree. Yeah, okay, fine. Okay, fine. Let's see. How do I want to do it? Oh, how do we want to do it? Is that true? Can we do a max tree? Like when you reduce the numbers. Does that work? I actually don't remember how to. Having a segment tree would be helpful, but I don't even know if it's gonna be fast enough. But it probably is. But still, Yeah, I'm just googling it up. I don't know how this works. Well, I do, but it's been a while. Oh yeah, that's right. Okay, fine. Like that, right? Scatter is fine. So now it's scatter. Let's see. Wait, what? Yeah, how do I use this again? I don't even remember how to use this anymore. It's so long. Yeah, a lot of people got it. No, I thought I had it. Oh yeah, I think I need to build one. But oh yeah, I know. It should be just. It's fine. Okay, this is not quite. This doesn't crash, but okay. So if it's available, now we have to do a binary search on this binary search, right? Then the middle is good, so we want to get earlier. And after that is that's that. Don't have any buy seats anymore, do we? Oh, we still do. Yeah. Oh. Should be zero actually. Yeah, okay. Yeah, okay. Okay. Seats left. So what did I have before? gonna get it? I don't know. Huh. Self.m. Okay, I didn't store it. I didn't remember I did. It's really bad today. But I'll set up do this update. Oh, you're right. Okay, is this at least right? Doesn't seem like it, to be honest. Okay. Okay, what am I doing? This one is returning wrong. Whoa is right. And then 4. Why is this wrong? Why is this wrong? Why is this giving me a 1 for first case? M is 5. Did I have before? Oh, I did count, that's why, okay. Oh. That's kind of why I had it, I guess. Okay, 004. Maybe not. Can gather 2 people. Let's put this back in just now. Okay. So 5 and then 5. That's quite clearly not right. Did we not update? No, this does update. Well, this is 5, but then afterwards. That's not right. We're doing it wrong, probably. Is this wrong? It's not recursing enough, is it? Oh, why isn't this recursing? I don't get it. What? It goes left and then it's already here? I guess so. Oh, because we only have 2 rows. Okay, that's maybe fair. But is it though? Why are we setting it to 5 though? Yeah, we shouldn't be setting it to 5, so I'm just doing something wrong here. So we're setting it to 1. Oh no, this is just, wait. Debugging seg tree. So it's not 1. Set it to 1, okay. I do the query one. I think this is technically right, maybe. Wait, what? No, it's 0, so why is... It's max total. Not knowing how to use seg tree really really to help this one. Okay, so it's 0 is max. No, this is definitely not right. Why? Why not? Last ditch debug, let's see. So 0 looks at 5 and 0. Look at 0, 0. Huh. This 5 isn't right. Am I supposed to do propagation? Why is that still 5? Right, 0. Oh, I forgot that I needed to. Everything is one index, isn't it? Because then now it's just doing it itself. Okay, I'm being dumb. I think. Yeah, okay, fine. Oh, that one index, this one should be 1. I forgot about that actually, it's been a while. Oh, this is not great, but it's supposed to be maximum. Well, this got open pretty quickly, so probably not. Hmm. Oh. Up. Oh, 9. First one is 247, that's fine. Push 21 rows, 941, 940. Hmm. $15 minutes? Don't know. We're definitely closer, but not close enough. 21, 941. Max row and also actual row. This is 0, so why would you still go in? This is fine, but this is which is accurate, I think. Maybe. That's not true. What is the row? Row is 0. Why do I always choose row is 0? Oh. Yeah, yikes. Maybe. Okay, this is... I don't know if this is good, but... no, it's definitely not good. Okay, well... it's better, but not good. That's good. Is the other answers right? Oh, I deleted it. The other answers are right-ish. Don't know if it's true, but... why is it doing 1 instead of 0? If it is... is my book wrong? Still the wrong answer here though, unfortunately. Why is this again? Two, 3, 2. uh, 0, 0, 1, 2, 2. 0, 0, 1, 2, 3, 2. Did I off by 1 or something? Oh, this is row. Six, 2, 8, but true 169. Is that true? 1, 2, 3, 4. Nope. Because this is way bigger, but wait, what? That off by 1? Oh, jeez. Okay. On eyeball, this looks okay. So let's give it a quick submit after removing the print statement. All right, let's give a quick submit. 7 minutes left. This is wrong. With time limits, I think I'm done though. But I don't think I can improve it that much. Yeah. Wow, a lot of people got it. Yeah, maybe I could do. I don't know how to do it unless the. I mean, if the algorithm is just. I mean, it may very well be that the algorithm is just a for loop, but that doesn't make sense. The first row that lets you get it. I mean, I have to write out algorithm, but it's definitely too slow. So yeah. I mean, I'm happy that I finally got segment tree, but yeah, I'm actually surprised that this time limits. This is just log, and I mean, there are a lot of constants obviously and recursions and stuff like that, but like I wish there was more context here. That's what I was trying to see, but yeah, I don't know. Maybe we could. Is this too slow? I don't know. That's why as well as converted. I don't know. Maybe I'm missing something really obvious on this one. I think this part was the trickiest one. Maybe I could have just done this. Let's see. I don't think this is quite true. That's why I didn't do it that way. But I don't even know how, like, if you decrease this, how does that work? Right? I don't know. I don't think that's right. You can combine these though. Maybe that's a little bit better. I don't know. Wow, I mean, I'm not fit to do videos, maybe. How do people... maybe I just got stuck on this mindset. That's also a possible thing where there is maybe a easier solution. That could be true. I mean, I'm happy that I got it right, just not fast enough. Don't even know why it's not fast enough though, but to be honest. Oh, whoops. That's what happens when you copy and paste. And also change the variable names for no reason. Alright, one more YOLO. Because I have no time. And then we'll look at some solutions and then see if I can figure it out. This is yikes. Okay, I mean, it's so weird. Because it's, this is log n. I thought log n would be fast enough, to be honest. It's either that or I have a crazy loop somewhere. It should be right. I mean, this is the only loop I have. I guess this loop, but it should be okay though, because I think this is pretty greedy. You only do it once. Yeah. Let's take a look at the solutions. I did it the same way, so I also did it with I did it both ways. I couldn't get it to work. Okay, I mean, wait, let's see. Maybe I okay, maybe I just needed to not have an extra binary search on it, but yeah. Sorry, I'm just looking at my Discord. I mean, this seems like binary search. I feel like people have done it the same way. Maybe it's just a Python thing. Yeah, I mean, it seems like people. So I mean, you might or might not know that Python is. Yeah. And I had to debug some stuff, but I mean, that's, just trying to test this real quick. I mean, I don't know what to say. Would this have run quickly on just this case? It may be that maybe it's just too slow for me. I don't know. Yeah. I mean, this took 9 seconds. But I don't know why that is though. I don't think I do anything duplicate. And it seems like it's just, the first row every time. And So that is just like like for this particular case, it's just login. I don't know. Yeah, I don't know. If anyone, I'm just trying to see if there's any like Python acceptors. Is this no, this I was gonna be like, yeah, I was like maybe they didn't do it with segment tree, but alright. I mean, I think so. One good thing is that I wasn't wrong about my solution. It's just that I guess I should have done it in C++. Seems like people just copy and paste. I mean, if I had enough time, maybe I would have done it in C, like I would have converted to C++. I was just, you know, as you saw, I did not have that much time, but just trying to see, I guess there's no one did it with. I mean, yeah, it seems like I mean, all right. Let's give it a quick spin on trying to do this with C++ and then record a day. That's kind of frustrating though, actually. That like I had the solution, but not really. So I don't know. Wait, let's see if there's anyone done it with Python. Okay, well. Wait, Java brute force? If that was what? If Java brute force works, that is hilarious. But okay, let's convert this into C++ real quick. And then yeah, Alright, I'm just gonna copy some ideas. I mean, I'm gonna still use my code, but I actually don't know how. Okay, it's been a while since I just want to make sure that okay. I mean, I guess we could just use local variables for it. I wasn't sure. Okay, seats. What are seats? I'm just looking at in C++ specific tips, to be honest, right now. I guess they just have a sig tree library, but which is fine. But do I really want to do it? I guess so. How do I I mean, if I had enough time, I definitely would have. Mm-hmm. 4 times, right? Is that how that? This is so not efficient, though. Like I feel like. But we're all learning together. But I mean, I feel like I'm still happy that I got it, obviously. Though I took a long time on that one still, to be honest. But I don't know. I mean, I guess people just copy and paste a solution or something, so I don't know. It is what it is. I did forget that the ID needs to be 1. That was a little bit silly on my part, but it is what it is. Alright, now I can maybe copy and paste this kind of. Okay. And now that I have a slightly better understanding of it, should be okay. Oh, I forgot that. In C++ land. I know this part is kind of boring. It is just me. It is just me typing things. But it does build muscle memory though, so I don't mind it that much. It's just annoying, that's all. I mean, it's just annoying that it was wrong to begin with. Oops. But I am very rusty about it, so maybe this is good for long-term things. Just trying to see it, make sure it compiles real quick. I mess this up. I did. No, I didn't. What does that even mean? Just recursive stuff over. Alright, let's try this real quick. Okay, so I probably have just off by once. Whatever. Also, maybe I need to clear it actually. What? Tell me why? This part I don't miss about C++ though. I thought it may be just out of bounds, but heap buffer overflow. What does that even mean? We'll Google that real quick. This index getting too big, is that it? Huh. Why? No, this is why, right? My original build. Yeah, this should be right. It does go over, but why? I used to print prints before it overflowed. Okay. 0200. Oh, yikes. Sorry, that one's my fault. But this is why you check, so that you can kind of along the way instead of all the way through. Okay, so that looks good. Let's do update and so these other functions. This way as well. I mean, I'm doing everything from scratch. Maybe I should have a library. I don't know. What do y'all think at home? The good thing is I am ready. As you can see, I can actually do this now without looking. But so it is better practice in a way. Though, yeah, because as a test I can. Oh, okay, I was gonna say as a test I can do the sum function, but maybe not. It's fine. And another update. Now I feel like it is good practice, even though. And funny enough, I was actually looking into this the other day. This obviously is not right. I hope I don't have any. Oh, now it's gonna. I have to deal with overflow issues, but yeah, okay, fine. I mean, there's really nothing I can do about it. I know that this isn't needed, but might as well. Oh, whoops. Okay. Come down, Larry. It's on the left, and the update. And then now at the very end we do the update on the thing. the thing. Okay, and then now we have to finish the gather. Is this part? That's fine. This is fine. I need a better thing for this. I think with seats is that M or N? Okay, fine. I just call it N. Of course, when in Zealand. Yeah, I know, but it shouldn't overflow in case of those of you who are thinking about it at all. Okay, nice. No, I think this actually no, whatever. I don't know. I don't remember. Well, I think that's right, but just called update, right? I didn't call max update. Yep. Okay. Now I know how to do it a little bit better, so let's just do it. Count. No, this is after I did it. That's why. Let's keep it in the same spirit. What am I doing? Well is true, and then it's M minus count, I think. Okay, let's at least see if it runs real quick. I thought I had it. Oh, push back. Now we just have to do the other part. Okay, that's actually pretty helpful. What are my test cases? Line 47. Again, no. Did I have this one? Shouldn't go recursively a lot, but I should not be that deep, so so why is this wrong, or why is this going recursive thing? It's just that this got stopped here. Alright, let's look at my max total. Maybe I do need to take a look. Return, yeah. I mean, we don't allocate that much memory anyway, right? Huh. I mean, I'm glad that this caught it, but why? Did I do it something wrong? Let's look at maybe it's max total 100n. Yeah, no, this looks okay this time around. Maybe here? No, that looks still okay as well. Huh. see. Yeah, this shouldn't be going that fast. Let's see what happened here. Or maybe I just had some typos or something. Yeah. Oh. So two, so it goes to 0, 1, and 1/2. And then now TL is equal to TR. Do I not? What did I do in the? Did I have this? I mean, this worked in my Python, right? That's so weird. Oh, I missed this part. Okay, so I was wrong about. Huh. Okay, so I mean, there's still something to learn. I tried to do this from memory, but clearly I actually forgot about this part of memory. So yeah. Oops, that's not it. Still much to learn. I mean, I want to be able to get it from memory, but maybe I don't care that much about it per se. Is that the only case where that happens? I guess so. Okay, that looks a little bit better. We have to fix this as well, but we don't use it yet, so we're gonna fix it while running. Just TM +1, Larry. Come on, man. Okay. I suspect this is okay now. Okay, well, you know, just slightly better now. Okay. I actually do expect the first answer to be right at least. So, that is interesting. Let's see. So let's debug that real quick. Yeah, that looks okay. So why is this wrong? Oh, I just forgot to return. Okay, well that's oops, that's actually wrong as well. But oh, I just why is this inside the while loop? Okay. Yeah, that looks better. And then now we have to do the scatter step. Scatter step, yeah. I mean, as you can see, even knowing it takes me too long to I mean, well, this is a little bit hard for me, but or new. It is new for me, but still, you know. Should we label it rows or something? I'm thinking whether I should. I guess it should fold in, but still. Okay. Is this good enough? I don't know. Let's see. Let's at least test the big cases, maybe. If it doesn't, then I spent half an hour for no reason. But okay, that looks fast enough. Okay, fine. I'm just posting it in my Discord. Just posting on Discord. Come by if you want to check that out. Apparently it's too long, but okay. I mean, I think that's all I have for this one. Again, I think Leetcode does not care about Python, so yeah. Thanks everybody. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's contest, especially that Q4. That's all I have. Stay good, stay healthy, to good mental health, and I'll see you later. Bye bye.